Welcome to another Intermediate Algebra video. Today we continue a little bit more with graphing. In this video we're going to look at graphing linear inequalities. So we have two objectives for this video. What we've seen the most of thus far with graphing is linear equations. And now we're going to focus on inequalities. So when we solve equations, we usually get one solution. It's possible to get more than one, but we've really only looked at linear. But when we solved inequalities, we get a bunch of solutions. So that's kind of what will happen here. But we won't be able to write those solutions in interval notation or anything. The presentation of the solution will be via graph. So we're going forwards and backwards with this kind of thing. We're going to graph the inequality, and then we will also write the inequality from the graph. So let's look at the going forwards version first, and some notes. So here are the steps for graphing a linear inequality. The first thing we'll do is graph as if the inequality says equals. So we have a few different methods to do that, and at this point you can use whichever one you want. But then our line will have a specific look to it. So if our inequality symbol is less than or equal to, not less than or equal to, less than or greater than, then the line will be a dotted line. So, dotted line. Something like that. If our inequality symbol has the equal sign with it, so if we have less than equal to, greater than or equal to, then it'll be a solid line. Everything that we've done so far was something equals something else, and so we've always had the equals involved. That's why we've always put a solid line. But now the equal sign may not be there. And so if that's the case, you'll just use a dotted line. The online homework system has the ability for you to put the dotted line in the picture. Okay, so first we will graph the line and choose the appropriate line to do so. And then we have to decide where to shade. So the big picture of these is that here's our inequality, and typically with a linear equation, our solutions are everything along that line. But with the inequality, it's everything on one side or the other of that line. So step 2 is choosing a test point on one side or the other. Doesn't matter which side. If we get a true statement with the test point, then we shade that side. If we get a false statement, then we shade the other side. There's other ways to test it, but this feels like a pretty simplistic way for me. So if you have another way of graphing a linear inequality, that is also fine, but this is the way I'm going to show it to you. All right, so here's the going forwards version. We're given the inequality, and we're asked to graph it. So the first thing we want to do is graph it as if it says equals. So what would this look like if it said y equals negative 2x plus 7? You have the option of graphing whatever way you want to. This one's presented in slope-intercept form, so I'm going to graph it that way. Let's build the graph. So we have a y-intercept at 0, 7. Right, there's our b value. And then our slope is negative 2 as a fraction, negative 2 over 1. So that tells us to go down 2 over 1. Okay, so we have the points ready for us to draw our line. But remember, then we need to decide what should this line look like. Should it be a solid line or a dotted line? For this one, we want a dotted line. And the reason? Our inequality symbol does not have the equal sign with it. It means everything along this line is not a solution, but everything that comes right up next to it is a solution. All right, so dotted line. Dotted line. Okay, because it's an inequality, there'll be some shading involved. And now we have to decide which side should be shaded. Is it this kind of top or right side, bottom, left side? And there's no simple way to just look at the direction of the inequality symbol to make the decision. We choose a test point. This is a little bit more grounded. So we can choose whatever point we want as long as that point is not on the line. If it's available, 0, 0 is always a nice choice. And 0, 0 is definitely not on this line. So 0, 0. Let's test it. So we plug 0, 0 into our inequality and see. Do we get a true statement or a false statement? So we have 0 is greater than negative 2 times 0 plus 7. 0 is greater than 7. This is what we tested. Is this a true or a false statement? 0 greater than 7. It's a false statement, which means 0, 0, the location right here, this is not part of the answer. So the other side of the line must be shaded. So then we shade. The shading continues for forever on that side of the line to infinity. I get the picture if you just shade next to the line like this. And it shouldn't cross over. You can come close to if you want it to kind of be really close, that's okay. But I get the picture if you're showing me on that side is shaded. So this tells us all of the ordered pairs that would make this a true statement are here on the kind of right upper piece of this line. Everything that we've shaded. Up to but not including the line. The line would make it equals, and that's not what we have. We only want y to be greater than negative 2x plus 7. All right, so let's do another one. For our second inequality, we have 2x plus 4y is less than or equal to 16. Again, it's your choice on how you graph this. If you want to continue to use slope-intercept, you can solve for y. For this one, I'm going to do x and y intercept. My x-intercept is when y equals 0. We want a value for x. And remember, this is so that we can ultimately graph the line if it said equals. So y equals 0, we have 2 times x plus 4 times 0 equals 16. 2x equals 16, x equals 8. So the ordered pair is 8, 0. Okay, then the y-intercept. We need 2 points. Y-intercept is when x is 0. So we have 2 times 0 plus 4 times y equals 16. 4y equals 16. Y equals 4. The ordered pair we get here, 0, 4. Okay, so let's graph the line. Go a little more. We have 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 0, 4. So here are the 2 points that connect to form our line, but now we decide what should that line actually look like. Do we have a dotted or a solid line? For this one, we have a solid line, and the reason we have an equal sign in the inequality. So the shading will exist on one side or the other, and it will go up to and include the line. The solid line tells you it's included, the dotted line tells you it's not included. Kind of like interval notation. Okay, so here's our line. And now we decide which side should be shaded. So choose a test point. That test point just has to be very clearly on one side or the other. I would not suggest for a problem like this choosing 3, 3. If you can kind of see, there we go, 3, 3. I wouldn't suggest choosing a point over here because it's hard to tell. We sketched this line, so it's possible that 3, 3 is on the other side of the line. So choose something that is just clearly on one side or the other. 0, 0 is available, so I'm going to go with 0, 0. Let's test 0, 0 and see what happens. We plug in 2 times 0 plus 4 times 0 is less than or equal to 16. We get 0 is less than or equal to 16. And this is a true statement, which means the side that has 0, 0 is the solution side. That's the side we shade. Again, you can add more sketches in there, get it closer. I get the picture if the shading is there. Good. So to review, on the going forwards version of this, we graph the line as if it says equals, using whichever method you want to. Make sure you choose the right type of line, dotted or solid line, based on the inequality symbol. And then choose a test point. Any test point you want. 0, 0 is a nice one, but you don't have to pick that. If you get a true statement, shade the side that contains that point. If you get a false statement, shade the other side. Okay. So that's the going forwards version. Now let's look at the going backwards version. You are given the graph, and we know it's an inequality because there's shading on there, and we want to build the inequality. So think about the things that helped us go forwards with this. Think about the things that helped us build what the graph would look like to be able to go backwards. One important thing we had was what type of line. In this first problem, we have a dotted line. And what does that tell us? What does that mean for the equation or the inequality that we're going to build? Dotted line means that we either have the less than or greater than symbol. So that already narrows it down. We know that the equal sign is not included. Okay, another thing we looked at to graph it was a test point. 0, 0 is definitely available. And we know that 0, 0 gives us a true or a false statement. For this one, it's a false statement. If the shading existed on top of 0, 0, that would be a true statement. But here, 0, 0 is false. And that'll be helpful. Okay, so let's hold on to those things until we actually have an equation. So we've seen lots of ways of writing an equation from the graph, so let's go ahead and find that. You can use whichever method you want, count, rise, over, run. We have lots of ways. I'm going to go with y equals mx plus b because I can clearly see on this graph the y-intercept, and then I see another point that I can count, rise, over, run to. So the y-intercept is 0, it looks like 8. 0, 8. And this other point over here is 6, 2. You don't really need the ordered pair if you're going to count, rise, over, run, but it can be helpful. So in our equation, we know that the b value is 8 plus 8. And then the slope, let's add this up here. If I count down from this point, so I'm going down 1, 2, 3, 4, 5, looks like 6, down 6, and then over 1, 2, 3, 4, 5, 6. Negative 6 over 6 simplifies to negative 1, so my slope, negative 1x. Now you don't have to write the negative 1 there, you can just write negative x, that's fine, it's the same thing. So this is very close. The only thing that's different is that we don't want equals, we need an inequality symbol in there. So I'm going to set up for both. We have two options. It's either that y is less than negative x plus 8 or that y is greater than negative x plus 8. Those are our two options. And this is where we use the test point. We've already used the dotted line to tell us it's one of these two inequalities. Now we use the test point. 0, 0 should give us a false statement. So which one gives us a false statement? If we plug in 0, 0 in this one, we have 0 is less than 8. And that's a true statement, which is great, but we need a false statement. Plug it into the other one. 0 is greater than 0 plus 8. We get 0 is greater than 8. And that's a false statement, which is what we want. It's not always what we want, it just depends on the graph. In this case, we need 0, 0 to be a false statement. So that makes this the inequality. Y is greater than negative x plus 8. Imagine taking this and graphing it. We're going backwards from that. So graph is if the line says equals. Okay, we know 0, 8. We know our rise over run. Down 1 over 1. Here's our line. Then we say dotted line because of the symbol not having the equal sign. And then 0, 0 give us a false statement, so we shade the other side. You're taking all that information and going backwards with it. So the fact that it's a dotted line means less than or greater than. The fact that 0, 0 is false means you need it to give you a false statement when you plug it in. Now, if you plugged into this first equation and immediately recognize, hey, this gives me a true statement and I want false, by default, it will be the other equation or the other inequality. So you don't have to test it in the other one, but it can be helpful. Okay, let's do another one. For this second problem, again, we have the same objective, write the inequality. And again, might be difficult to see, but we have a dotted line here, which means that our symbol is either less than or, greater than. Oh my goodness. Or less than. You don't have to write them in the same order. Doesn't matter. And that 0, 0 gives us a true or false statement. Again, false here. Okay, so then we need to write the equation of the line. We have this information that'll help us in the end, but now we need the equation of just what this line is before we can decide how the shading will affect it. Remember, this is a special type of line. You can use those other methods of finding the inequality or finding the equation to write this, but this is a special type. This is a vertical line. What kind of equation does a vertical line have? Vertical line is an x equals line. X equals, and all of the locations are 4. X equals 4. Okay, but now we know that it has to use one of these two inequality symbols. Ooh, that is not an equals. So it's either that x is greater than 4 or that x is less than 4. Ooh, let's move that up. And this is where the test point comes in. Our x is 0. We want a false statement. So the first one, 0 is greater than 4. Is this true or false? 0 greater than 4 is false. We want a false statement, so this is our inequality. X is greater than 4. We wanted false because the shading does not have 0, 0. This is one of the only times you can use where it's shaded. It's all of the numbers that are bigger, so it'll read x is greater than that number. I still like the idea of using the test point as a way of kind of verifying for yourself. So this is the going backwards version. We went forwards, we've gone backwards. Now you can practice. One of each in either direction. Graph the inequality, don't forget to shade, and write the inequality from the graph. If you cannot see, the shading is on this side. All right, go ahead, pause the video. We'll go through everything when you're ready. Okay, so our first inequality, y is greater than or equal to 3x plus 5. This one's in slope-intercept form, so I'm going to start by graphing y equals 3x plus 5. Not good. Let's make it a little lower. All right, so here's our setup. Our y-intercept is 5, 1, 2, 3, 4, 5, 0, 5. And then our slope, 3, or 3 over 1. So up 3 over 1. Now, what kind of line should we have? Our inequality symbol has an equal sign, so we will have a solid line. And then we decide where to shade. We can choose a test point anywhere you want to. It doesn't have to be 0, 0, but zeros are nice to deal with. Let's test 0, 0. 0 is greater than or equal to 3 times 0 plus 5. 0 greater than or equal to 5. Is this true or false? This is a false statement, which means 0, 0 should not be shaded. It should be the other side. So there's the shading. This is what your line should look like. As looked at previously, if your line is a little bit left or right of what you're seeing, it should have the same general features. It should be a solid line. From left to right, it should be going up. I should be able to see some ordered pairs that helped you build that line, and then the shading should exist. Okay, then let's go the other way. We want the inequality here. Start here. Good. Okay, so let's build the equation first. I definitely see, oops, in red again. I definitely see the y-intercept and then another point here that I can count, rise over, run to. So I'm going to go with slope-intercept. You can do it whichever way you want to. My b value is 1, 2, 3, 4. And then the slope, if I count, is down 1, 2, 3, 4, and over positive 2, which simplifies to negative 2. So the equation would be y equals negative 2x plus 4. Okay, we have a solid line, which tells us either less than or equal to or greater than or equal to. And 0, 0 gives us a true statement for this problem. All right, so we have the inequality or the equation. We want the inequality. It has to be one of these two options. Let's go higher. Y equals greater than or equal to negative 2x plus 4. So test one or the other. You need 0, 0 to be a true statement. So let's plug it in. 0 less than or equal to negative 2 times 0 plus 4. 0 less than or equal to 4. This is a true statement. I want a true statement, so this must be my inequality. This helps you to get to this place. This is the inequality for the graph. Y is less than or equal to negative 2x plus 4. Okay, so this video looked at the going forwards and the going backwards version of graphing inequalities.